Okay, now let's start the lecture 7, which is about the Dirac delta function. Okay, before we introduce the Dirac delta function, let's first look at one function we have learned before. In previous lectures, we have introduced this function, v equals to 1 over r squared, and the direction of this v, actually v is a vector function, and the direction of this v function is r hat, means v is directed radially outward. And the picture of this vector function is shown here. So let's use the pencil here. So if you pick up any point or any location in this function, you will figure out the direction of this vector function v is going outward radially. And if we calculate the divergence of this function, and actually we did it before in the previous lecture when we learned the del operator. So del dot v finally equals to 0 means if you choose a location, arbitrary location, or any location in the space in the function, you will figure out there's no vectors flow out or in, or the net flow in this location is 0. That's the divergence. However, we didn't mention that if you pick up the point at the center or origin, then the thing is different. So let's see. The divergence of this vector is 0 at any place except 0, or origin except the origin location, because it can't be at the origin, because 1 over r squared, r cannot be 0. Otherwise, this value will be infinity. So the conclusion we have made before is the divergence of this v function is 0 at any space except origin. Okay, so if you remember this conclusion, divergence of v equals 0, then keep it in mind. We will use it soon.